Hi everyone, and thanks for coming to the talk on the epic NHL goal celebration hack with the hue light show and real-time machine learning. So this talk is about a hack that I did during the last NHL season, during the playoffs. And I did a blog post about it and a little YouTube video. And this was about having a great light show and party whenever the Canadiens scored a goal in my living room. So without saying anything more about it, I'll just show you a little demo. So that was just a clip of a video. So this was actually pretty exciting. So I did the blog post and in the video and put this up, and it actually kind of got a lot of traction on Reddit and the Hacker News, and the video got 100,000 views in about a week and a half, and even some coverage on CBC and Washington Post. So that was a kind of nice little surprise there. So a few words about me. My name is François Maillet. I'm the head of machine learning for a startup in Montreal called Dataset. We do machine learning, and I'm currently working on a new product called the Machine Learning Database, which is super exciting, and it's free to try, so I encourage you all to go check it out at mldb.ai. Before that, I studied computer science and machine learning at the University of Montreal, and I did research on music-related problems such as playlist generation and music recommendation. So in this talk, I won't show you a bunch of Python code. Everything's on the blog post in a lot of details, but I'll go through kind of the steps that I went through to put it together, the kind of gotchas, and if you want more details, everything's in the blog post. So how did we get started with this? So essentially 2 years ago, a friend of mine lent me this great USB button that I had on this little table in front of my couch in my living room, and whenever the Habs would score a goal, I just jump and press the button, and the older goal song that I love would play, and that was great. But can we take it further? So last year, I was talking with colleagues, and we were talking about this, and we kind of wondered, could we somehow make the goal song start by itself through some automation. But on top of that, I had acquired a bunch of Philips Hue lights in my living room that I just used to create a nice ambiance. They're pretty fun, so could I also make them flash to the music? Keeping in mind that the kind of big problem with this, the really hard part, is that it's got to go fast. You can't because we thought of looking at if this then that, scraping some website, looking at Twitter, anything like that, push notifications. But if you think about it, you're watching the hockey game with your friends, and your team scores, and then it takes 1, 2, 3, 4, 5 seconds. Okay, now it starts. You kind of miss the moment, right? You need this to go off as soon as your team scores. And there's no web service that I found that could kind of do the job in that respect. So I needed something else. So the kind of intuition that is behind this hack is having worked on audio before, I kind of thought about it. And during a hockey game, you hear a bunch of stuff, but some things sound different than others. For example. So that was a French commentator saying something. Even though most of you probably don't speak French, you probably have an idea that something happened there, right? There was a goal and a goal horn. So there's a lot of cues in the audio. If you're watching the game blindfolded, probably you could figure out that there was a goal. So then I said, could we use the audio feed? And that led to the foundation of this hack, which is 3 different components that kind of work separately. first of all, the thing we want is the light show. So we want the flashlights and play some music. So that's that. We need some machine learning to do the real-time audio processing and to basically tell us, is there a goal? And we also need to hook this up in such a way where we can do real-time detection during an actual game. So just so you have an idea of the setup that I have in my living room, I have an AGTV with a Mac Mini hooked up to it, and that's hooked up to my sound system, and my cable subscription allows me to stream the game off the internet, so I can actually play the game in the browser and route the sound wherever I want to do some processing. So everything's going to be running on the Mac Mini. All the great Python libraries that I used to put this together. So I said that we were going to solve this with machine learning. So this is going to be a binary classification task, meaning we want to set apart two types of things. In our positive class, it's going to be the Canadiens scored a goal. That's what we're trying to detect. And the negative class is kind of the Canadiens did not score a goal, so anything else. Another way to say this is we're trying to model the probability of the Habs scored given some audio. So what I did is I went on the Habs website and they have a section with game highlights for all the previous games in the season. So if any of you have experience with data science or machine learning, you know that at some point in your project, you're going to be feeling like a monkey. And for me, that was spending a couple evenings recording audio highlights of that website and taking down the exact time in each clip where a goal for or against the Canadiens occurred. And I put all of that in a nice CSV file, so I had a data set. So that's great. But I said we're going to be using some audio to use with the machine learning. So for those who aren't familiar with machine learning, the way it works is that you give examples to a model, and the model will try to use different kind of optimization and statistics to figure out how to separate your two classes. Another way to look at this is you could imagine that we're trying to separate, C++ programmers and Python programmers. The computer doesn't have any idea what a C++ programmer is versus a Python programmer, but we need to give it features, a numerical representation of each of the classes so that they can set them apart. So for example, features could be the company that they work at. It could be their age. It could be the length of their beard, for example. So we use audio features, and we use a great library called librosa, which basically gives you kind of all the most used audio features that you can get in a really easy to use format. So here at the bottom is a waveform. Probably you've all seen this before. We're not going to use this directly. We're going to make a transformation on that. And on the other side, it's a spectrogram. So basically, the x-axis is time, y-axis is frequencies, and it's a heat map. So the color tells you the amount of energy present at that frequency time pair. And the great thing about that is you can actually see the patterns. You can see what the audio looks like. And this is at the basis of almost every kind of smart audio processing system. What we actually use is the Mel power spectrogram, which is just a spectrogram with an extra level of transformation on top of it to make it look like more like the way the human ear perceives sound. So I said you could see patterns. So I don't know how well you can see it from the back, but this is the Mel power spectrogram of a Habs goal, and I highlighted the goal and the goal horn. And you can see in the goal section, there's big wavy lines going down. That's the commentator saying, "Et le but," like that. And the goal horn is straight lines because, it's a goal horn, so it's pretty constant. So that's great, you can see it. So maybe the algorithm is going to be able to pick up on that. Now, a question I often get was, well, how did it, set apart the goals for and against the Habs, right? Well, let's take a look at a goal against the Habs. Much smaller. And I kind of got lucky with this because I watched the games in a French station in Montreal, and as many of you can imagine, the Francophone commentators are a bit biased towards the Habs. So when the Habs score, they go nuts. But when the other guys score, they kind of say, oh, goal, let's forget about that and move on. Which is not the case for a network like CBC, right? It's a national network. They try to be more unbiased and balanced. So had I done this with CBC, maybe it wouldn't have worked at all.
Did you do anything with row games?
Well,
did you do anything when they weren't at home?
Yes. So this is actually when they're not at home, which is why there's the goal horn. Well, I'll get back to that. So, okay, so we have our Mel-power spectrogram. That's great, but what the model needs is an actual feature vector, a long list of numbers. So we simply vectorize it. So it's like a matrix. So we just take every line, stick them one next to the other, and that's a very big feature vector that we can use for our model. Now this is the probably simplest thing that I could have done. The reason for this is I woke up with this idea 2 weeks before the playoffs, and I was like, I'm on the clock. I need to get this done for game 1. So everything I did was the simplest approach, and I was kind of surprised that this worked. So some people said, couldn't have you done speech recognition and then try to look at what the commentators were saying? Well, maybe, yes, it's a lot more complicated. So I just started with this simple approach, and it ended up working. So now we're able to represent 2-second clips of audios as a feature vector for the machine learning models. Now we need to actually assemble a training data set. So we need to explicitly tell the model, these are good things, look for these, and these are bad things, we don't want these. So naturally, because of what we're trying to do, the positive examples are the goals by the Canadiens. That's what we want. And so for the negative examples, I'd like you all to close your eyes and imagine Saturday night, hockey night in Canada, epic confrontation between the Toronto Maple Leafs and the Montreal Canadiens. Everyone in their living rooms are at the edge of their seat. And then the unthinkable happens. The statistical anomaly occurs. The Leafs score a goal. I know it's hard to believe. It does happen sometimes. But on top of that, the very worst thing that could happen is the light show starts. So not only did we just get scored, the algo's trolling us about it, kind of laughing, right? So as explicit negative examples, we need to give all the goals against so that the model is able to differentiate what does a good and bad goal sounds like, which is probably why it's not using the goal horn, because the goal horn can be present in both cases. Also, we randomly select 50 segments from every highlight to give as negative examples, so the model can also learn what a normal game sounds like. That way, it has a good idea of everything that can happen during a game. Then we just used a great library that probably most of you know, scikit-learn, and I used the simplest off-the-shelf algos to do this, because again, I was trying to get the simplest thing working. So logistic regression and SVMs. I could have done neural nets, could have done deep neural nets. Probably that would have worked a bit better, but this got kind of reasonable performance considering the very simple features that I was using. But thinking of the context in which we're going to be using this, it's important to keep in mind that there's a difference between a prediction and the decision that we're going to take. Meaning that we can make multiple predictions and use a bunch of them to take an actual decision. The decision being, there's a goal, let's start the light show. So what I wanted to do, since I'm going to be using this on a stream of audio, live audio stream, I can permit myself to make a bunch of predictions and use many to have a more robust decision process and try to bring down the number of false positives. So this is an example to show you kind of how this works. So I'm going to start this video. You're going to see things moving. This is a 2-second clip of audio that's going to be moving forward in time. I'm sorry, and on the right, it's the log probability coming out of the model. So, the red lines there are just saying the log probability is above some threshold, but I don't have to look at only one. As I said, I can look at many. And I played a little bit with different decision heuristics, which were looking at the last 20 predictions, and they needed to be above a certain threshold, or looking at the last n. If you're above a certain threshold, you're voting yes, and we need a kind of number of positive votes. The way that I did this was doing a 10-fold cross-validation. I had 10 games in my data set, so I would train on 9, test on the 10th, and rotate them such that every game gets tested on once. And I would look at these metrics to kind of figure out the best set of decision heuristic with hyperparameters. So the different things that are important to us is, first of all, the Habs scored a goal and we got it. This is great. This is what we want, and it's fun. The second one is my example with the Leafs, right? The Leafs scored and the light show starts. This is the absolute worst that can happen. We need to keep that as low as we can at all costs. Then no goal occurs and the light show starts. This happened once during the playoffs. It was the national anthem, and the light started, which is funny once, but you try to also keep that down. The last one is the Habs score and there's no goal. That's kind of boring. You talk about your friends about the hack. They come over, the Habs score with just one goal, and your thing doesn't work. So then you're like, do you really have a hack that's working? So what I ended up using, SVMs were better, more recall, but worse precision. So too many false positives. So I used logistic regression, and the trigger was 5 positive votes in the last 20. Threshold was 90%, and so these are the cross-validation results. Looking at the statistics from the season before of the Habs, of the average number of goals for and against, you can kind of look at these numbers to say what we expect. We're going to not detect 0.84 games on average per game, and we're going to go off by mistake once every 4 games if the Leafs score. So you always have to make that kind of threshold decision. How much wrong answers are you willing to let in? Because if you try to get this down to 0, then you're going to start not detecting Habs goals. So the only way to make that better is a better model, better features, more data. And I didn't quite have time, so I decided to stop there. These stats were kind of acceptable for me. So we have a machine learning model that can score WAV files on disk. That's great. That was the most risky part of this hack that I felt like. So once I had done that, a light show. 2 parts to the light show. First, we need to play the epic goal song called Le Goal Song by a band called L'Oreille Cassée, which was the goal song like 10 years ago at the Molson Center, it was called back then. But also flash the Philips Hue light. So for those of you who aren't familiar with them, they're really awesome, smart LED lights. Just normal bulbs that you can put in whatever light you have. And it comes with a hub that you plug to your network, and you have a phone app that you can use to set the intensity, the color of the lights. So they're really nice, not just to flash the lights, but also, just as I said, to create a nice atmosphere in your living room. When researching how to make this work, I realized that there's an API running on the hub, on the Philips Hue hub. So you can connect to it and just say, set this light to this intensity and that one to that color. That's how the iPhone app works. So what I did is I found this library called phue, which is great. Wraps this API in nice objects and classes. This is the only code I'm going to be showing, but because it's so small and nice, this is how you flash lights in your living room. You just import the package, connects to the bridge, set some color codes. I took the app, looked at one light. I said I want blue, so I selected blue, took down the color code and did that for a couple colors. And then it's just for loops, right? You're just rotating through your lights and just cycling through colors and sleeping at the end, and then that's how you get flashing lights. So I spent a few evenings, and at the time I didn't have blinds, and looking out from my living room is a huge condo building. And so I spent evenings just playing the song and tweaking the for loops so that it would line up with the music. And a few times I would look out the window and see a bunch of people just looking at me. Like, who is that guy? What is he doing? No kidding. And I wrapped all of this behind a REST API of my own. So that way it's nicely decoupled and stands on its own. So yeah, I have the light show API that I can call with the /goal endpoint that'll start the music, start the light show. Now the last part of this, we actually need to make it work with an actual game. So as I said, I'm running this on my Mac Mini. So I found a piece of software called Soundflower, which adds virtual audio devices to the Mac. That way you can set your system output, audio output to Soundflower, and then use a Python package called pyaudio to essentially connect to the Soundflower virtual device and get the audio into Python. That was a bit tricky to get working. I got a kind of big example on the blog. So the way it looks like is stream the game in your browser, send the audio to Soundflower, pyaudios getting the audio from Soundflower and sending it out to the HDMI output so that we can listen to the game. But before sending it out, it's going to take the frame and send it to a little buffer. I'm keeping 2 seconds worth of audio in a buffer that as soon as I get a frame, I'm just scoring it. So I'm just scoring 10 times per second as the audio moves through. And looking at the last predictions in my decision heuristic. And if then we decide that there's a goal based on that, we can call the endpoint and start the celebrations. But I'm still using that good old USB button that I talked about from 2 years ago because, as I said, it's not perfect. And if you're there and it makes a mistake that is not starting when the good guys scored, or, as I said many times, started when the opposing team scored, you need to either start it or stop it quickly because it's not going well for you. And just to remind myself that it's important to keep working on this and make it better, when it did start by mistake and I had to force stop it, the sound that it played for me to remind me, work harder, Frank. Yeah. So now the hack was done. That was great. To kind of do self-promotion on the internet, I put together a nice YouTube video. So I use matplotlib, and I did this probably in one of the least efficient way possible. I'm sure that someone here knows of a better way to do this, but I essentially generated the frames one by one using matplotlib of the graphs that I showed you before moving. And then I had hundreds of PNG files that I just stitched together because I had 2 graphs generated separately, stitched them with ImageMagick, so like in the shell, and then converted that to video using FFmpeg. Ugly, but works. And then I assembled that with like iMovie with shots that I took of my living room. So what's next based on this, right? So the system has no problem detecting every goal. That's not the problem. The problem is some goals, it's not sure if it's good or bad goals. So one of the simple ways that I thought of maybe solving this was to just train a simple model based on the image, which I didn't do to begin with because it's more complicated, or I don't know it as much as well as sound, but just a simple question: which goaler is on the screen? If you can answer that, you can probably bring the other model's accuracy to 100% because there's no question, right? If you know that there's a goal and you know which goalie you see, then you got it. So that's one thing. And the other thing is it's very specific because of the features that I'm using to, the one guy, commentating the game. I tried this on the second Francophone station, didn't work at all. Tried this on CBC, didn't work at all because it's really, really, trivial features will give you, a result that's, so I essentially overfit that one guy. But they were airing the playoffs, so that was fine for me. But moving forward, probably this is something that I could look at to try to find better features that will generalize better. And essentially, this is it. So I think we have time for questions. So thank you for your attention. Hopefully, we're all still friends after this. Yep.
So you were saying you were using 2 seconds of audio for feeding to the model to make a decision whether your goal is scored or not. How much of a clip were you considering for the goal? So if the goal hit, was it only 2 seconds immediately after, or were you considering up to 10 seconds past, or how do you decide the variable or block length of the audio to feed into the model?
For training it?
Yeah. So like, did you only do the 2 seconds immediately after the goal was scored, or did you do more? Because as I noticed, you cut the horn out and all that. Was that always only 2 seconds, or was it sometimes like 5 seconds?
Right. I actually didn't cut the horn out. I'm assuming that the model decided not to use it because it would confuse him. But I essentially took a couple examples around the kind of time that I had. Yeah, a little bit on both sides. Since I'm scoring in like continuous fashion, that's why probably also it works well with many predictions, as you'll get like the closer the kind of actual goal yell from the announcer comes at the middle of like the frame, then it probably starts going up because it's kind of hitting those frequencies. So little jitter around the actual goal. Any more questions? Yeah.
Maybe I missed it, but how did you explain to the model that there are two types of mistakes, false positives and bad false positives? Can you penalize during the learning procedure differently based on the impact of the error you're making?
That's a really good question. You can, but I didn't. But I could have added extra weight to the examples that represented goals by the opposing team, so that the model would kind of conceptually try harder to get these ones right during training. So I didn't explicitly do that, but it's possible to do that. You could say like these ones are costing me more if I get them wrong. These ones are getting me more value if I get them right. So I'm going to weight them accordingly in training so that the model spends more learning capacity getting the ones with the higher weights.
Would it be possible to implement some sort of Twitter live feed to differentiate between goals scored by the Habs versus somebody else?
Yes, possible, but kind of, as I said at the beginning, I think that it would be too slow to get the feedback from Twitter to take a decision. It's probably will take at least 5-6 seconds for someone to tweet something, and by that time you already either started or didn't start the light show.
Are you against using any sort of metadata, like seeing if it's a home game or an away game or something like that, like looking up the game?
If I'm doing that?
Oh, are you against doing that? Like,
I'm not against anything. Okay. If it works, for me, I didn't. It wasn't. I think useful considering what I was doing, but maybe for if I was using the image, then knowing which side my team is on, and they're always on the same side based on if they're home and away, that would be using the game metadata could be a way to actually figure that out.
Is the next step now to extend it to all the other sports?
Maybe, but again, I'm not sure how well that would kind of scale to other sports in this state, because I think that I'm writing on the fact that the commentators are so explicit in expressing their joy, and at soccer they go nuts too, but are they going nuts only for one team or not? So I didn't try it, but since looking at the way that it failed so miserably on like the CBC games, probably would need another passive feature engineering to figure out smarter features for this task. Question? Okay, cool.
So did you try doing like closed captioning analysis or just your audio?
No, I didn't try, but you're not the first one to suggest that. I maybe could have. Again, there's a longer delay than doing it this way, and to be honest, I'm not sure if I'm getting that in my kind of stream on the internet. So to use it, then I'd have to find a way to pipe it through Python somehow, which was a complicated thing to figure out how to get the audio in a real time. So then the closed captioning would be another kind of thing that I need to figure out how to get into my program in real time as it's happening. But if it's fast enough, definitely, then maybe you could you could know who's got the puck, right? It would be kind of replacing my image analysis thing. If you simple NLP maybe could give you hints with regard to if they have puck possession or not. Oh. So we're out of time, but I'll be around, so I'll be happy to answer any questions.